If we look at the option Greek, so this is now looking at time to expiration. So this is getting at theta. Here we're looking at 3-year options. What happens to the price of a 3-year option as we keep all of the parameters constant, price constant, everything's constant but time. And you can see that when everything else is constant, up here we have a strike of 30. This is a call. So this is way in the money. This is at the money. And this is out of the money, has a strike of 50. And you can see that if it's in the money and out of the money, the price almost drops linearly. Namely, theta is relatively independent of when you calculate it. That the theta for an option, if we divided the 3 years by the number of days in 3 years, we would get the theta per day, the negative theta per day, and it would be pretty constant. You'll notice that an at-the-money option has a somewhat nonlinear effect right at the very end. The nonlinear price, the price of the at-the-money option drops linearly until you get to a certain point in time, and then it drops, the theta increases. It drops faster. And the reason is simple, that when you're farther out, you still, even though it's at the money, you still have significant time value in that option in hopes that it's going to get a payoff. But as you get closer and closer to expiry, any hopes of that at-the-money option producing a payoff go away. And we know it has to converge to zero. It cannot converge to, that looks like about $3. If we just extended that line linearly, it would say an at-the-money option would converge to $3, which makes no sense. It has to converge to zero. So what one finds is in the money and out of the money options have thetas which are pretty constant over time. And in the money options and out of the money options have thetas that are fairly constant with time. But if you have an at the money option, it'll decline in value much faster toward maturity than it does earlier because of, if you will, the elimination of hope of a payoff. So here are put option thetas for a strike of K and at different stock prices. And what you can see is, in general, the thetas are negative. In other words, this is a put option with a strike of 40. And if you look at stock prices 35 and larger, pretty much the theta is negative. That means that the price of the option drops with the passage of time. It'll drop faster for the 3-month option. It's going to drop faster because at the very end of the option's life, it's going to drop quicker, as we saw on that graph. The longer ones drop slower. And then you'll see this phenomenon that when this put option gets way into the money, in fact, the option starts appreciating in value over time. It has positive theta. As it gets shorter, the value appreciates, and that's because you're getting closer to the ultimate payoff. So it appreciates more like a T-bill.